Today we're going to finish up our discussion of lesson 99 that we began yesterday about how to correctly solve a rational equation. Just to review from yesterday, what did it mean that you had a rational equation? You have an equation that contains some fractions, and specifically within those fractions you have a variable in the denominator. Since there is a variable in the denominator, as we learned, we have to be careful to look for what was called an extraneous solution. The extraneous solution was an answer that did not satisfy the original question because it made a denominator equal to 0. If that is the case, then we had to eliminate the extraneous solution. We could not give that as our final answer, as we saw in the last example that we walked through yesterday. In the process that we talked about yesterday, there was always two fractions that were equal to each other, and if there was two fractions equal to each other, we were able to cross multiply to help us come up with our final answer. That was the first method that we learned for how to solve a rational equation. Well, today we're going to learn a second method to solve a rational equation, and this is because there is not just one fraction on each side of the question. So method number 2. What we're going to do is we're going to knock out the fractions from the entire question, and then we're going to proceed to solve just like a regular algebra problem. Well, we've done that already this year. How do I correctly eliminate all of the fractions from a question? We multiply by the least common denominator. We learned in lesson 95 how to correctly pick out the least common denominator. It was everything that we saw the most times that we ever saw it in the question. So when I multiply by the least common denominator is because I have more than one fraction on each side of the question, and I cannot just easily cross multiply to help me come up with our final answer. I have 3 questions that we'll walk through together, picking out what is the common denominator and then correctly using that to help us continue to solve. So the first question, 9 over 3x plus 15 over x is equal to 6. I cannot just cross multiply because I do not have one fraction on both sides of the question. The fractions that I have on the left side can't be combined together right now either because they don't have the same denominator. So our method number 2, how do I solve when I have multiple pieces on a side of the question? I'm going to multiply by the common denominator. So what do I have for the common denominator on this question? Again, that includes everything that I see the most times I ever see it. Well, the first fraction has a number in the denominator 3, the second fraction doesn't. So that means I do need to include the number 3 as part of my common denominator. The first fraction also contains an x, and it has one letter x. The second fraction also has an x in the denominator, and there's just one of them. So what was the most letter x's that I saw per fraction? 1. So I'm going to take my entire question, I put it inside parentheses, and I'm going to multiply by the common denominator, and that's the 3x that I have on the outside of our question. Now, like I taught you guys earlier this year, I think the easiest way for us to multiply through by this common denominator is actually to work with the denominator first. What I'm going to do is I'm going to take this common denominator that we just picked out, the 3x, and I'm going to divide by the denominator first on each individual fraction. Then we're going to multiply by the numerator. Okay, so watch what I'm going to do here. I'm going to start with just the first fraction. 3x is what I'm multiplying by, and if you want to, you can put that as 3x over 1 if it helps you to see it as a fraction format. The 3x from the common denominator would cancel completely with the 3x from the denominator. So 3 divided by 3 would be 1, and x divided by x would also be 1. Well, after I divide, I multiply by what was on the top. So what was my answer on division? It was 1 times the numerator. 1 times 9 gave me 9. And there's my 9 that I have right here on the question. Now I'm ready for fraction number 2. Again, I'm going back to the original common denominator of the 3x. Now, in the second fraction, I'm going to be able to cross off the x. This x in the denominator can cross off the x from the common denominator, but I'm still going to have the number 3 left over. So what do I do with that number 3? I'm going to multiply it by the 15 that I had originally in the numerator, and I wrote that off to the side here, 3 times 15. Now, this last number, the 6, isn't a fraction if you want to. You can put it over 1. That way you can see them all in fraction format. Well, that means this 3x that I'm using in the question, that wouldn't eliminate anything. because I can't cross the 3 off and I can't cross the x off. So I have both of them left over. The 3x is going to get multiplied by the 6. So again, what did I do? One fraction at a time, I saw what would cross off. The first fraction crosses off the 3 and the x, so I was just left with the number 9. The second fraction only crosses the x off, so I had the 3 and the 15 that was in the original numerator. The last piece didn't have anything in the denominator, so nothing crosses off, so I have the 3x as well as the number 6. Notice the question that we now have written doesn't have any fractions, and that's an equation that's much easier for us to solve at this point. How do we continue to solve? We have two multiplication steps that we need to take. On the left-hand side, 3 times 15 is 45, and on the right-hand side, 3x times 6 is 18x. The left-hand side of the question just has two constants, so let's put those together. 9 and 45 gave me 54, and that is equal to 18x. To finish getting the x all by itself on this question, I need to divide by what's in front of the x, which is the 18. 54 divided by 18 gave me 3, so there is my potential answer for x. Again, before I say that definitely is my final answer, I need to make sure that it's not an extraneous solution. If I were to take this 3 and put it back into the original question, well, 3 times 3 is 9. That's okay. I can have a 9 in the denominator. If I put 3 right here for this x, well, again, I can have a 3 in the denominator. So I know that this answer is perfectly acceptable for me to use. And actually, this one's pretty easy to check all the way across as well. Remember, 3 times 3 was 9. So 9 divided by 9 would give me the number 1. If I put 3 into this denominator, 15 divided by 3 is 5. Well, what am I supposed to do with those two numbers? I'm supposed to add them together. So 1 plus 5 gave me the 6 that I had on the right-hand side of the question. And I know for sure that my answer is the correct answer on our question. Again, you don't have to do that entire checking unless you really want to, but you have to check the denominators to make sure that they don't make 0 when you put your answer back into the question. All right, so let's go through two more examples together. The first fraction, I have 12 over x plus our second fraction, 15 over x plus 1 is equal to the last fraction, 72 over 3x. Once again, we cannot cross multiply because we have two fractions on that left-hand side of the question, and I can't just put them together because they don't have the same denominator. What is my new method for this kind of question? We're multiplying by the common denominator. The common denominator is everything that I see in this question the most times I ever saw it. When we picked out the common denominator in lesson 95, the first thing that we did, we started with any numbers that you had that weren't part of adding and subtracting questions. Well, what do I have down there that's just a regular number? The 3. And that's the only number that I see down there that's not part of adding and subtracting. So I do need to include that 3 as part of my common denominator. What else do I have? I have this letter x out here in the front, and that's not part of adding or subtracting. There's one of them sitting here. This x is part of adding and subtracting, so I'm not going to worry about that one yet. So I have this one letter x, and over here I also have one letter x. Well, what was the most times I saw it? Once. So I need to include the x as well in my common denominator. The last thing that I see in the denominator is this entire addition problem of x plus 1. I just see one of those addition problems, so the common denominator that I need to use has 3 different pieces. It was the number, just the number 3. We saw one letter x. There was one here, there was one over here. So we included one letter x in our common denominator. We had this one addition problem, so I put it inside parentheses so I could see it as the entire addition problem. It needs to stay in its entirety. The yellow part of the question is the original problem that was given to us on the original or on the question. Okay, so how do I do this question? Again, if you want to, go ahead and put this over 1 so you can see it in its fraction format. Fraction by fraction, what's going to be able to reduce? Well, this first fraction has an x in the denominator, so it would cross off this x, not the one that's part of the adding, the one that's not part of the adding. So this x knocks off this x, so I still have the 3, the x plus 1, and the 12. So I wrote all three of those pieces right next to each other, and I just put the 12 next to the 3. So I had all the numbers first, and there's my x plus 1. I dropped down the plus sign from the question. Let's go to fraction number 2. In the denominator, fraction number 2, I have an x plus 1. Well, what would that cross off with from the common denominator? It would make the addition problem of x plus 1 go away. Again, this x does not cross off the x in the front. It crosses off the entire addition question. So what would I have left? I have the 3, the x, and the 15. And those are the 3 pieces that I wrote right here in the middle of our question. Again, I just put the 2 numbers side by side. The last part of our question in this denominator is a 3 and an x. So what would it cross off with? The 3 and the x that was out in the front, which means I have the addition question left over of x plus 1, as well as the 72 that was in the numerator, and there's my 72 times x plus 1. Okay, so fraction by fraction, what would it cross off with from the common denominator? The pieces that you have left are going to get multiplied together in your question. So what I did, I tried to show this step by step so you can see exactly what I'm going to do. The first thing on that first part of our problem, I did 3 times 12, which gave me 36, and I still have the x plus 1. On the second part of the question, there's my 3 times 15, so I have 45 that goes with my x, and I didn't distribute yet on the right side because I'm just doing one thing at a time. I was just multiplying any just regular numbers that I could first in the question. Now we're going to go ahead and distribute into both of the parentheses that I have. So on the left-hand side, 36 times x was 36x. 36 times 1 was 36, and we drop down to plus 45x because that's not inside of a parenthesis. Equals. Distribute on the right-hand side, 72 times x is 72x, and then 72 times 1 is 72. On the left-hand side, we have a couple like terms that we can collect. There is a 36x that we can put together with a 45x. So 36x plus 45x gave me 81x. We still have our plus 36 is equal to 72x plus 72. There are no like terms on the right-hand side of the question. The problem, once again, has x's on both sides of the question, like we saw on the last problem. How do I get those x's together? I'm going to take the one from the right-hand side and subtract it to the left-hand side. How do I move that 72x? By subtracting it. So 81x minus 72x gave me 9x. We still have the plus 36 that was there originally. Then the right side just has the 72. Continuing to solve, I got to get rid of the 36. So to do that, I'm going to subtract it over. 72 minus 36 gave me 36. So 9x equals 36, and then divide by 9. So x equals 4. Again, before I say I'm done, that's my final answer. Is the 4 an extraneous solution? If I take a look at denominator number 1, it just has an x. So that means I would replace it with a 4, and that's okay. I can have a 4 in the denominator. The second fraction says x plus 1 in the denominator, so 4 plus 1 is 5. Again, that's okay because I can have a 5 in the denominator of a fraction. The last one, 3x. So 3 times 4 is 12. Again, that's okay because I can have a 12 in our denominator. So the 4 is not an extraneous solution. Again, I could check it all the way out if I really, really wanted to, but I think if we're careful with our arithmetic, the answer that you get should be the correct answer. So let's try one more question today with this idea of a common denominator. We have 3 over x minus 1 minus 2 over x is equal to 5 over 2x. The left-hand side has 2 fractions, so once again, I cannot cross-multiply on this question. We're going to try to eliminate the fractions by multiplying by the common denominator. How do I pick the common denominator? Just like we've done already, I'm picking everything that I see the most times I see it in the question. Beginning with just my regular number, which is the 2. That's the only number I see down there, so I need to include that 2 as part of my common denominator. What else do I see? I have this letter x that's not part of adding or subtracting, as well as this letter x that's not part of adding or subtracting. There's one of them here, there's one of them here, so the most times I see the x is just once. The other part that I have in the denominator is this entire subtraction problem of x minus 1. So my common denominator, once again, has 3 pieces. Our number 2, the x that was not part of adding and subtracting, and the subtracting part of the question of the x minus 1. The yellow part is the original question that we started off with. Let's go ahead and see what would cancel out fraction by fraction. So the first fraction has an x minus 1 in the denominator, which means it would cross off with the x minus 1 that I have here in green. What am I left with then? The 2, the x, and the 3. So again, I put the 2 and the 3 side by side, so I have the numbers together, and there's my x. I drop down the minus from the question. The second fraction has an x in the denominator, so it would cross off with this x that is not part of the subtraction question. What do I still have? The 2, the x minus 1, as well as the 2 from the numerator over here. So there's both of my number 2's, the one from the common denominator and the one from the numerator, as well as my subtraction of x minus 1. The last fraction has a denominator, the last fraction has a denominator of 2x. So what would it cross off with? It would cross off with the 2x that I would have in the front. So I have the subtraction problem left of x minus 1 as well as my number 5. So 5 times x minus 1. Just like the last question, again, I'm going to try to do this step by step here. So the first thing I'm going to do is just multiply the numbers. So 2 times 3 gave me 6x. Then minus 2 times 2 is 4. I still have that parenthesis of x minus 1. And then the right side didn't have just any regular numbers to multiply, so that stayed the same. Now the next thing that we did was distribute. Now we got to be careful here on this question because as we go to distribute, this minus sign that's in front of the 4 needs to get distributed to both of these terms that are inside of the parenthesis. So the 6x keeps moving right down. Negative 4 times x was negative 4x. Negative 4 times negative 1, so careful there with your signs. Negative 4 times negative 1 was positive 4. On the right-hand side, that's just positive 5. So 5 times x was 5x. 5 times negative 1 was negative 5. On the left-hand side, we have two terms that we can put together, are 6x minus 4x. 6x minus 4x is 2x. Then I got plus 4 is equal to 5x minus 5. On the last question we saw, the next thing that we did was we put the x's together. Again, my preference is I always put the x's on the left-hand side. If you want to put them on the right-hand side, that's okay. So how do I take the x from the right-hand side, which is the 5x, and move it to the left? I would subtract. So 2x minus 5x gave me negative 3x. And we still have the plus 4 on the left-hand side and the negative 5 on the right-hand side. Because we put the x's on the left, the numbers need to come to the right-hand side. How do I move my 4? I'm going to subtract it. Negative 5 minus 4 is negative 9. And now I'll finish by dividing by negative 3. Negative 9 divided by negative 3 is positive 3. Again, before I say I'm done, let's make sure that doesn't give us a 0 in a denominator. The first denominator was x minus 1. Well, 3 minus 1 is 2, so that's okay. The second denominator was just x, so I would put a 3 in the denominator. Again, that's okay. The last fraction said 2x, so 2 times 3 is 6. Again, that's okay because I don't see any zeros in any of the denominators. So what did we learn today? If we have multiple fractions on a side of the question, we cannot cross multiply. We're going to multiply by the common denominator. The common denominator includes everything that I see from the original problem the most times I ever saw it. After we determined that common denominator, we looked fraction by fraction for what would it cross off with, and then we proceeded to solve from there.